You're welcome. So let's get into some more questions, okay? But before that, there's something that you have to take note of. You see, in deriving the forms of the equations of a line, you can see that it always goes in hand with what? A vector and a point. But be careful. It's not just a vector, but rather a vector from where? A direction. You have to be careful with this concept because when you find the cross product of two vectors, you will get what? A vector. But that vector is also a vector, and the two vectors that you cross them together is also a vector. But there is a difference between the two. When you do a cross product between two vectors, that two vectors is the vector from a direction, but the result is the vector from a normal. Be careful with it, as I said, lines and plane. So when you do a cross product of two vectors, you get what? A vector from a normal. So in order to get an equation of a line, you need a point and a vector from the direction. Alright, good. So let's work on some examples and let's see how we are going to derive some things. Alright, so first example. Good. Of the equation. But remember what I told you. Before you can get all these steps, what do you need? A point and a vector. But not just a vector, but a vector from a direction. Alright, so how do we get a vector from a direction? Good, let's move on. So now we have, from the question, we have been given the initial points, so no problem. We know that the P is 5, 1, 3. We also know our vector from a direction to be V is equal to 1, 4, negative 2. Alright. So writing the component form will not be difficult. We know the component form is in the form this. Right? Or you are forgetting. And the x naught, the y naught, and the z naught is split on this side, plus the a t, plus the b t, plus the c t. And we know that this x naught, y naught, and the z naught is the initial point, which is 5, 3, 1. And the a, b, c is the 1, 4, and negative 2 respectively. Therefore, the component form will be equal to x naught is 5 plus the a is 1 times t. So you get that. Alright? The y naught is coming from the point, which is 1 plus bt. So the b is what? Negative 2. So that will clear up this, so 2t. Then we have the z to be 3 plus, but we know our c here, the b is 4. Alright? Then we know our c here is the negative, so that will clear up this, negative 2t. Alright, so that will be the component form of the what? Of the equation. I. Let's go to the I. That is the Cartesian form. So you know the Cartesian form. You have the point and you have the vector, so don't worry. The Cartesian form starts with x, y, z, which is any point. B equal to then the x naught plus comma the y naught, comma the z naught plus t multiplying the a, b, c. So that is the general form of the what? Of the Cartesian form. So here by doing the substitution, then you get this is already here. So you're going to get 5, 1, 3 plus t. and the ABC is there 1, 4, negative 2, and that gives the Cartesian form. Alright, let's move on to the other one. Hope I can clean it. Okay, so let's go to the III, which is the parametric form. We know the parametric form is in the form S is equal to A plus what? Sorry? S0 plus what? 80. That is for the first one. So here, S is equal to, you know the S0 is coming from the ordinate of the what? Of the point, which is the first one, 5. Plus the A is here, 1. So here is T. That's our first point. Then you go for the Y. And the Y is equal to Y0 plus what? Don't forget, it's plus, it's not minus. Plus BT. So we have Y is equal to, and the Y ordinate, you get it here, which is 1. So here is 1 plus, or we can see that, the B. And the B is coming from the vector, which is 4T. So you get that. Let's go to the Z, which is Z0 plus CT. And that one too, you know our Z0 is 5. Sorry, our Z0 is the Z ordinate, which is 3. Plus the C, which is the negative 2. So that one will play off this negative 2T. Alright? So this is the parametric form of the equation. 1, 2, 3. What is next? The symmetric form of the equation. Don't worry. You know that once you have the parametric form, writing the symmetric form, it gets you making T the subject in the what? In the parametric form. So don't worry yourself. But know that it's in the form T is equal to you have forgotten. I will give you a technique. Okay, don't worry. So that will be S alright. So that will be S minus S naught. S minus S naught over A being equal to Y minus Y naught over B being equal to Z minus Z naught over C. Watch. You can see that this form of the equation, the vector is found in the denominators. The A, B, C is the vector. And always, the any point subtract from the specific point. So that is that. Don't forget that what we have here is minus, but no plus, the general form of it. Alright. So S minus, what is S naught? The S naught is 5. Good. What is A? Which is 1. Right? Y minus Y naught. Y naught is what? 1. Over the B, which is 4. Equal to Z minus Z naught. And Z naught is 3. Over the C, which is negative 2. So that will be the parametric form of the what? Of the equation. And the same as you picking this, that, and making T the subject. That is it. Because if you are making T the subject of this, it will be S minus what? 5. Here, Y minus 1 all over 4. Simple. Alright. Let's see if we can get I can get one question for you again. Alright. So we have our second question on the board. Now with this question, I will not end solving it with you. You continue it on your own. But let me help you with something small. You see, in the first example, we were given the initial point and the vector, so no problem. But here, what we have here is that we have only two points, which is A. 2, 4, negative 3, and B, which is 3, negative 1, 1. And we have to find the parametric equation and the symmetric what? Equation. You can also find the other form to it, no problem. But what we have here, they are all points. But what do you need to get those forms of equation? You need a vector from a direction and the initial point. Good. Then you need to use this. Please, this is the initial point. The first point given you is always the initial point. So with the help of these 2 points, then you can use to derive your what? Your vectors. So solve it and I'll get back to you. Alright? Alright? Wow. So that's how you are going to go about it. So with the help of the 2 points, you get your vector. Then you choose the initial point. So using the initial point, which is the first point, which is the A, and then your new vector you are having now. So then you come back to the first idea from the first example, which is the parametric form, the symmetric form. Thank you. See you for the next video. Bye bye.